So to find the angle, the horizontal and vertical components of the velocity are needed. The horizontal component can be found using conservation of energy for the initial acceleration of the electron. That component is not changed as the electron passes through the plates. The vertical component can be found using the vertical acceleration due to the potential difference of the plates and the time the electron spends between the plates. So first, the horizontal component, the potential energy initially for the horizontal component is going to be equal to the kinetic energy final. Okay. Well, the initial potential energy is the charge, Q, times the voltage, V, which is going to be equal to the final kinetic energy, which is 1/2 the mass. Since this is the horizontal component, this is V sub x, the velocity in the x direction, squared. Okay? Where time here, of course, is going to be equal to the distance traveled, so delta x, which was given, divided by the velocity of x, V sub x. Okay, so now for the vertical component, the force here is going to be equal to the charge times E sub y since it's vertical. Okay, well, this is going to be equal to the mass times acceleration since it's force, which is equal to the mass times V sub y minus the initial V sub y, which is 0, divided by the time t. So solving for V sub y, we find that this is equal to the charge Q times E sub y divided by the mass, then multiplied by the time. But the time is delta x divided by V sub x. So I just replace time with delta x over V sub x. Okay, so now we're going to combine those to find the angle, since tangent theta is equal to V sub y over, so V sub y over V sub x. Well, V sub y over V sub x is equal to Q times E sub y times delta x divided by the mass times V sub x squared. Okay, well, this is equal to E sub y times delta x. Okay, then plugging in the value for V sub x, the q's cancel, and we have 2 times the potential voltage V. Okay, so to find theta, we have to take the inverse tangent of both sides. So theta is going to be equal to the inverse tangent here of what's in these parentheses here. We know all the values here, so you just plug those in and then take the inverse tangent of that, and we find that this is equal to 16 degrees. And we can box that in as our solution.